Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 4. This is Section 11.1, Problem 4. It says, consider the function f of x equals x squared plus 10x over 5x and find some different limits. So part A, you want to find the limit of x squared plus 10x over 5x as the input value approaches 0. So I'd like to just put in a 0 for x and see what happens. Again, we're not really putting a 0. We're putting in values really super close to 0. But because of the 5x in the denominator, I cannot just put in a 0 for x. On the top, it's fine. But the bottom being 0 is something I cannot do. So I want to cancel that x somehow. So we have to do some sort of factor and cancel for this. Now, you might be tempted to cancel x on top, x on the bottom. You can't, because it's a plus in between the x squared and the 10x. If it was times, you could just cancel 1x. But what I have to do is really take the limit as x approaches 0. And in the numerator, x squared plus 10x both have an x. So I can pull an x in front of the parentheses and make it into x times x plus 10. The 5x is still in the denominator. And then cancel x on top, x underneath, and take the limit now as x approaches 0 of x plus 10 over 5. So almost forgot the 5. So now I can let x approach 0 because the denominator doesn't zero out. So what I wind up getting when I put in a 0 for x, and again, I'm not really putting in a 0 for x. I'm putting in things super close to 0. The x plus 10 gets super close to 0 plus 10 over 5, or 10 over 5, which I can reduce to 2. So even though I cannot actually put a 0 in for x in this function, as I put in values for x very close to 0, the output or height on the graph I get will be getting very close to 2. So that's the answer for part A. Now B says take the limit of the same function, x squared plus 10x over 5x, as the input approaches 5. Now, because I can actually put in a 5 wherever I see an x, I don't have to factor anything and cancel it. As I put in things super close to 5, it's really the same thing that's going to happen as when I just put in the 5 and see what the output gets closer to. So now when I put in a 5 for x, the x squared on top becomes 5 squared plus 10x becomes 10 times 5. And then 5 times x underneath becomes 5 times 5. And now I'll simplify the math. The 5 squared that I started with, 5 times 5 is 25, plus 10 times 5. 10 times 5 is 50. In the denominator, 5 times 5 is 25. Now again, you cannot cancel 25 on the top, 25 on the bottom, because it's a plus in between on the top. If it was 25 times 50 on the top, you could cancel the 25s. But I cannot because it's a plus. 25 plus 50 is 75. And I have 25 underneath. Now I can reduce 75 over 25 reduces to 3. So as I put in values for input values very close to 5, the output is getting very close to a height of 3. So for part C, find the limit of the same function, x squared plus 10x over 5x, as the input gets very close to negative 5. Now again, because I can just actually put in a negative 5 where I see an x, what happens is I get super close to an input of negative 5, and what happens when I actually put in a negative 5 as an input will be the same thing. So I can just put it in and see what happens. I don't have to factor things and cancel them out the way I did in part A. So in the numerator, the x squared will be getting close to negative 5 squared, or second power. Again, pay attention to the signs. The 10x is 10 times x, or in other words, 10 times negative 5. And in the denominator, 5 times x will be 5 times negative 5. So now start doing the math. Negative 5 second power. Negative 5 times negative 5 is positive 25. And now 10 times negative 5, it's plus a negative 50. So instead of writing plus a negative 50, let me just do minus 50. So I have 25 minus 50 on top. And underneath, 5 times negative 5, again, pay attention to the signs, 5 times negative 5 is negative 25. So as I simplify the numerator, 25 minus 50 is negative 25. And in the denominator, I have another negative 25. So negative 25 over negative 25 reduces to 1. The 25's cancel, the negatives cancel, I have 1. So as I put in an input that's super close to negative 5, the output is getting closer and closer to an output of 1, or a height of 1 on the graph is what it would mean.